We're going to work through your 1.3.1 homework. So the first part of 1.3, which is where we get into truth tables. So the first part of this assignment is just to get the general negation, conjugation, conjunction, disjunction, and conditional truth tables in there. And I would use these beside your homework and your tests moving forward. So these are just going to be a quick way to reference back to like the patterns of truth tables. So first one, truth tables are used to determine if a compound statement is true or false, given all true or false combinations of simpler statements that make up a compound statement. So we're going to start super simple. We are going to start with the negation, which again is the denial of P. All right, so I've got P and not P in here. All right, and so when you set up truth tables, you start by splitting the number in half. First half is all T, and the second half is all false. So really the only options for these are P is either true or P is false. And if we're denying P and P is true, well then the opposite is false. And if P is false, then the opposite of false is true. So the negation, the opposite, the denial, is always the opposite. So if the regular statement is true, the opposite is false. If the regular statement is false, the opposite is true. Right? That is always true for the negation. Next, we got the conjunction, which is when we combine the joining of two statements with and. Okay, and for this, both statements have to be true for the. So I'm going to write this here. Both statements must be true if we want for the conclusion to be true, for the conjunction. Okay, so the conjunction both need to be true. All right, so we've got P, and now we've got a second statement, Q, and then we have the joining of P and Q. And remember, it's the A, kind of upside down A without the line across it. And I remember that by thinking, okay, it's the word and starts with A. So P and Q. So when we fill out the P column, remember half of them are true. So the first two are true. The second true or false. This is just kind of a systematic way to list all of our combinations. And then you split the half in half. So this one could be true, but this one could be false. This one could be true, or this one could be false for Q's. So that takes care of all the combinations of our statements, P and Q. Now, both statements must be true for the conjunction to be true. So if P is true and Q is true, this conjunction is true. P on this one is true, but Q is not. So they're not both true. So the conjunction is false. Now these, we automatically know these are false because P is not true, and they both have to be true. So as soon as you see an F in a conjunction, you know that it's false. They all have to be true. All right. Disjunction is the combination of two statements with or. Okay. The joining of two statements with or. All right, and so then the disjunction is true if P is true, Q is true, or both. This one's a little bit more flexible for truth. All right, so this column is going to be P, this is Q, and this is P or Q. So it's the upside down A or a little V symbol. Fill out our regular combinations for P and Q. And we split this. All right, so now if both are true or at least one is true, we have a true statement for disjunction. We need at least one truth. So these are both true, then the disjunction is true. P is true, F is not. Well, at least one of them's true, so that's true. F is not, or sorry, P is not true, but Q is, so that's true. But then both of these are false down here, so that means the disjunction is false. Okay, so that's just kind of setting your basic tables up. So now we're going to construct a truth table for the following statement. Maria drinks tea, or she drinks black coffee and not sugary coffee. So we need some statements here. So we're going to first list just the general A, B, or sorry, what am I saying? P and Q, and then we're going to build a truth table. This is going to actually be 3 statements, so I want a good pen. All right. So I'm going to list these over here. P, I'm going to make the statement Maria drinks tea. Q, I'm going to make the statement Maria drinks black coffee. And R is going to be the statement Maria drinks sugary coffee. Okay, so there are 3 possibilities. So I need to build those in my table. And these are going to be 3 separate statements. So we're going to need 8 columns, or sorry, 8 rows, I should say. So this is P, Q. Build this flow. And R. All right, we got P, Q, and R. We're going to have 8 sections over here because it's 2 to the 3rd power. There's 1. I'm just kind of estimating this, so I hope I have enough. 2. 4. 5. 6. 7, and 8. All right, so I've got 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. Okay, we got P, Q, and R. So when we fill these in, again, if we've got 8 possibilities, I'm going to list all of my true and false here. So half of it would be 4 truths in a row, half of 8, and then the rest are false. Right, the next half of these are going to be true. The half of the trues are true, and then the rest are false. So every 2 match. I went true, true, false, false, true, true, false, false. And then every half of these truths are true. So that's true, that one's false. These are all going to alternate. Okay, so I've got our general table here all set up with our possible combinations of P, Q, and R, but now I need to write the statement for this. So Maria drinks tea, that's P. We have P, or disjunction. She drinks black coffee, which is Q, and not sugary coffee. So here's and, not sugary coffee is not R. Okay, so we need a truth table with not R would be the first one. Let's get that little mini guy in there. So here's not R. And then we have Q and not R. That's a conjunction. And then we have the final one, P or Q, not R. Okay, so I see how I just kind of worked from the inside out. I'm going to get all of these truth tables set. So I've got not R. So not R is going to be the exact opposite of the R column because that's a negation. It's going to negate all of the R values. So if R is true, then not R is false. This one's true, false, right? And it's just going to keep this opposite pattern all the way down. Opposite of R each time. So I just compared this one to get this one. Now I'm going to compare between the Q column, this one, and not R. So I'm comparing these two columns all the way down where my fingers are, and I need the conjunction. So they both have to be true, right? And they both have to be true for it to be a true table over here. So true is for Q, false is for not R, so this is going to be false because they're not both true. So this one is false. Q and not R are both true here, so this is true. These are both false, so false. So again, I'm just looking for where both are true. That's when I get a truth. Here's another one, that's true. Both false, that one's true and false, so false. All right, and then the last one, I'm doing P or this column that I just did. So I'm comparing the P versus the red, Q and not R column, so these two where my fingers are. And if either one, this is a disjunction, P or this whole thing. So if either one is true, then this column is true. So let me grab a third color, I guess. So because P is true, this thing is true. Again, these are both true, so the disjunction's true. P is true here, so the disjunction's true. P is true here, so the disjunction's true. These are both false, so this is a false here. P is false here, but Q and not R is true, so at least one's true. These are both false, and these are both false. All right, so construct a truth table. This is it. This would tell us that that this is true. This statement is true unless she does not drink tea and drinks black coffee and sugary coffee. So if she will drink both, then this is false. Or if she doesn't drink any of it, coffee, black tea, and sugary tea, then that's not true. So if she only, so here, I'm gonna write this down just so it's super clear. So this statement that they made here, this statement, Maria drinks tea or she drinks black coffee, not sugary coffee, is false if, here's the first false, if she does not drink, actually if she drinks either, that's kind of what I'm concluding here. If she does not drink tea and drinks either coffee, okay, or if she doesn't drink, or if she only drinks sugary tea, that makes sense. Sugary coffee only. all right? Or if she doesn't drink any. Okay. So those are the three cases where that statement would be false. Next up, we're going to talk about conditionals. So let's get a truth table going for that. Okay, so this is the joining of statements if P then Q. All right, so this is viewed as a promise. So the rule for this is it is only false when P is true and the conclusion is false. Okay. So that's the only time that it's false. Every other time it's true. All right, so I've got P and Q, my general table, true, true, false, false, true, false, true, false. Okay, so it's only false when P is true, Q is false. So P is, they're both true, that's true. This is P implies Q. Now here it is, P is true, Q is false, so this is false. If we switch it, that's true, and they're both false, that's true. So this is our general table for the conditional. All right, so then we've got this, construct a truth table for the following statement. If it is raining, then the streets are wet. So we need to list our conditionals. We're going to call P, it is raining. Q is the streets are wet. All right, so we've got P and Q here in our regular setup. Half are true, half are false, and then we alternate to get every combination. All right, beautiful. So then P implies Q is this statement. P implies Q. If it's raining, then the streets are wet. So we've got true, true. That is true. If it is raining and the streets are not wet, that is false. That does not make any sense, right? So that's not true. If it's not raining and the streets are wet, that is possible, right? Because maybe it snowed. And then false, false, that would also make that true. If it's not raining, then the streets are not wet. There you go. So that is your truth table there. We could write this is true unless, I'm going to go to this one, it is raining and the streets are not wet. That is not true. All right, so that's it for your 1.3.1 homework.